multiplying fractions. It's not too hard. Down here is the only one you might need to simplify. You can simplify ahead of time, or you can multiply and then simplify after you multiply, okay? But go ahead and work through these. Check your answers with mine. Make sure I'm doing them correctly. Okay, so the last one, there's two ways to simplify it. Vaughn, how would you like to do it? I pulled your stick. You want to simplify ahead of time, or do you want to multiply and then divide by something? Okay. Yep, okay, so let's go ahead and divide now. What's the greatest common factor for 3 and 6? 3. So what's 3 divided by 3?
1.
6 divided by 3?
2.
Okay, so 1 times 5 and 4 times 2. Now, those of you who went ahead and multiplied first, did you get 15 24ths?
Yes.
What did you divide by?
3.
I wonder if that's a coincidence that we divided by 3 for both.
Oh.
Cool, isn't it? So 15 divided by 3 is 5, 24 divided by 3 is 8. Same answer both ways. Okay, this lesson is about moving away from how we drew it yesterday to the area model. Okay, so as we're doing this application problem, I want to remind you how we did it yesterday, but we're not going to draw that. Okay, so let's start by putting a rectangle on here. You're going to need a rectangle. And then I'll read the problem. Now, the rectangle is going to be an area model. So it doesn't matter how big you make it. You just need to be able to write on the top and both sides and possibly the bottom. You remember the area model from multiplication? It looked like this.
Yeah.
And we'd put if it was 24, we would put 20 and 4. And 63, we put the 3 at the top, didn't we?
Yeah.
So we put the 60 down here and the 3 up there, okay? So this is going to be similar to that, but not exact. All right, so I'm going to read the problem and then we'll get it on there. Mrs. Golden wants to cover her 6.5 foot by 4 foot bulletin board with silver paper that comes in 1-inch squares. First of all, she needs to get on Amazon and order a roll of silver paper, doesn't she? Yeah.
You said 1 inch instead of 1 foot.
1 foot. How many squares does Mrs. Golden need to cover her bulletin board? Will there be any fractional pieces of silver paper left over? Explain why or why not. Draw a sketch to show your thinking. Okay? So the first thing I want to do is let's change 6.5 feet to a mixed number. 6 and, go ahead and tell me. 6.5. So right here, I want you to write 1/2. That's going to be 1/2 foot. And then 6 feet. And then the width is going to be 4 feet. So write that on the side. Now, go ahead and put your pencil down. I want to remind you how we did this the last 2 days. So we went ahead and drew boxes to represent all the tiles that we would need. And we even wrote down 1/2, and then did we put 1s in all these? And we would have counted all those, right? Okay, let's not do that. You agree? Okay, so we're going to take out that step of drawing all those boxes, and we're going to use what we learned with the area model way back at the beginning of 5th grade. So here's the area model. I take whatever's on the side times what's on the top. So what's 4 times 6? So I'll just write 24, and it's going to be feet squared because this is the area of the rectangle inside. Okay? Then I'll take 4 times 1/2. This is where I want you to write it down below, just so you can remember our strategy. So when you take a whole number times a fraction, it's like 4 copies of 1/2. So I'm just going to multiply the whole number times the numerator. So it would be 4 halves, correct? And could that be a division problem?
Yes.
What's 4 divided by 2? 2. So the area of that tall, skinny rectangle is 2 feet squared. Okay? So then we just add those 2 up like we used to in the old days with the area model. And so you're going to write 24 feet squared plus 2 feet squared equals 26 feet squared. And that's the total area. Okay? So she's going to need how many squares? 26 squares. The only problem is 24 of them are going to be whole. And then the last 2, so 24 of them are going to be 1 foot squares. The last 2, oh, that was bad. Pretend that's a square. What does she have to do with them? Cut them in half, right? Okay, so a total of 26. Will there be any fractional pieces of silver paper left? No, why?
Because there's no. She bought the exact amount.
Well, I think she probably bought more than she needed, but she cut only 2 squares in half, right? So what's a half plus a half? Okay, so going back to yesterday's way of doing this, if we kind of circled our holes, okay? So if she cut 2 of them in half, was there anything left over? No, she used all 4 halves, didn't she? Okay? So it says draw a sketch to show your thinking. I think we did it well enough, don't you? Okay, so let's go on to today's lesson. Now, 2 things are changing. Number 1, we're using an area model. So you're not going to put all those 1s and halves and whatever in there, okay? You'll just write on the outside and do the math inside. The second thing that's changing, both sides are fractional weights. So we're going to take a mixed number times a mixed number, okay? So you need to stay with me. All right, so last time we did this, first of all, you go ahead and get a rectangle on your paper. Just about like that. You're going to need to draw 5 of them on there, so give yourself enough room to draw 5. Since it's an area model, no, don't draw all 5 now. Just do 1. Since it's an area model, I don't have to make it the exact same size and shape as this one here, okay? So then I just start with my 1s, don't I? Yep. And I see how many 1s will fit. You think it's a half?
Yeah.
Okay.
Another half but sideways.
Another half but sideways, okay. Now, I'll be honest with you. This green rectangle is not the perfect size. Can you just ignore that fact? Okay. Because when I turn this half on its side, there's going to be a little left over. I think. If I remember correctly. Yeah, see? It's not perfect, is it? So, then, duplicate. And I made a little cube for you because I knew we were going to need it. And it's okay if you don't know the measurement of that because I'm going to show you how to figure it out when we get to the area model. Okay? So this is what tiling would look like. All right? So what I'm doing now is I'm going to recreate this in an area model, and I'm going to start with my fractions. So see how I left room at the bottom and on the side to put my fractions, okay? So at the top, how many one whole do I have?
4.
At the top, 4. So this will be 4 units, and then 1/2 units. This is all you put on your rectangle, so draw it now. On the side, this is the width. How many whole do I have? 2. And then I have 1/2, okay? Now the area model, watch what I'm pointing at. You're just going to go 2 times 4 and 2 times 1/2, 1/2 times 4, and 1/2 times 1/2. Think you can handle that? Okay, so what's 2 times 4?
8.
So 8 square units, because we did the area of this rectangle. 2 times 1/2. Okay, so if it helps you to write it down, this is going to be 2 halves, which equals what? 1 unit squared. So that's the area of this rectangle, okay? Now 4 times 1/2, I think we just did that. That was 4 halves, wasn't it? What's 4 divided by 2? 2. So this is going to be 2 units squared, just this rectangle right here. That doesn't look like 2 units, does it? It is. And then this little one, we're going to go 1/2 times 1/2. So don't say anything. Let's let everyone think it through. So what's 1 times 1?
1.
And what's 2 times 2?
4.
So the area of this little square is what? 1/4 unit squared. Okay. Now I forgot to put my length and width on here, so let's do that next. So I forgot to write the length. What's the length? 4 plus 1/2. 4 1/2. And the width, 2 plus 1/2. 2 1/2. And we're getting ready to figure out the total, okay, the area. So here's what I want you to write down. What's up here? We're going to add all these up, okay? So I'm going to write them all, even though I don't need to. That's going to be my total area. So you write them all. Write that addition sentence. Lexi, when you're done writing it, tell us the total.
The total is
11 1/4 units squared. Okay, so that's the lesson. That's what we're doing today. We'll have different sizes of rectangles to tile. Then we'll transfer it to the area model. Does that make more sense now? Yes. Why did you write it on there? I just can't see it. Can I? Okay, got it. The second one. So this rectangle appears to be a little longer. So go ahead and draw a rectangle. You don't have to make it be exact. And I'm going to start dragging tiles. Okay, you can stop talking.
I think it'll be like that box.
3/4 sideways.
Yeah, like that box.
No, it's going to be that and then the low cube.
The big cube.
Yes,
Okay. Got it. Okay. So we'll figure out what the area of that small box is in a minute. Right now, what we need to do is the length across the top. What is it? Okay, so draw a line for your fractions. Draw a line for your fractions. This will be 1 unit. and 3/4 units. So let's go ahead and put that on the chart. 1 3/4. Now what do I have here along the width? 3 and 3/4. So let's go ahead and put that on the width. And then we'll figure this out. Okay, so multiply 3 times 1, 3 units squared, because it's the area of this rectangle. 3 times 3/4. Let's write that down. 3 times 3/4. I'm going to pull a stick. George A. Tell me the fraction and then the mixed number. What's 3 times 3? 9/4. Remember, when it's a whole number times a fraction, you don't change, oh my goodness, you don't change the denominator. So it's 9/4. Turn that into a mixed number. 2 1/4. If doing it in your head is difficult, can you do long division? You sure can. And it will give you the same answer. 4 times 2 is 8. Okay. So right here, I'm going to write 2 1/4 units squared. Okay, so now I have 3/4 times 1. Any number times 1 is the same number. So what is it? 3/4 units squared. 3/4 times 3/4. Oh, let's write that down. We'll pull a stick. George V. 9/16. So the area of the little box is 9/16 units squared. Okay, so what do I have to add up?
All of them.
All of them inside. So I'm going to write them down in a row, and I'm going to write 3 plus 2 1/4 plus 3/4 plus 9/16. And then I can figure out what it is. Okay. Cheney, is there any of that I can add up ahead of time? The 2 whole numbers. So that's going to be 5 plus 1/4 plus 3/4 plus 9/16. I'm writing down my thinking here. Okay, what else, Emiliano, can I add up ahead of time? The fractions. Which ones?
1/4.
You got it. So it's going to be 5 plus 1 plus 9/16. Okay. Chloe, what's the answer to the problem?
Well, 5 plus 1 equals 6.
Good. 6 and 9/16. So now I know my total area. And I can write it on the chart. How you doing? So we're doing the area model, adding everything up inside of it. Okay? The next one's a little trickier. But it's fun. Okay, now on this one, I might just have to use my tiles to measure the width and length. Okay? So I want to start by, always start with 1 hole. So it's 1 hole's too wide for the top, isn't it? Okay. So do you think it's 3/4 or 1/2?
3/4.
Okay, so let's see if it's 3/4. It is. Okay. So I'm just going to leave those there right now. So here's what I know. I'm going to make a rectangle over here. I know the top is 3/4 units. And then to measure the length of the width, or the side, it's going to be one hole.
So,
You want me to try this one sideways?
maybe one half.
It's not 3/4, is it?
To the side.
So maybe try 1/2 to the side. Now there's a chance your teacher was not using her reading glasses when she made this, so it's not perfect. But is that closer than the 3/4 was? Yeah. Okay, so now we have a length. I mean a width. What is it? 1 and a half units. Okay. So let's get that on the chart. This is rectangle C. It's 3/4 units long and 1 and a half units wide. Now we're going to solve it. Okay. So 1 times 3/4. 1 times any number is the same number, right? So 1 times 3/4, 1 copy of 3/4 is 3/4. So, yeah, I made this really big. But this rectangle, the top part is just 1 by 3/4. Okay? So the next one, 1/2 times 3/4. Write that down. Josue? Oh, he's not here. How about Beverly? What's my answer to this? 3/8. So this is where life's going to get fun. So how do I solve this? I have to add these up, don't I? Oh, 3/4 plus 3/8 equals. Is that a common denominator? It is? No. These are unlike units. Can I add unlike units? No, I cannot. So I have to change them. About out of room, aren't I? Get rid of this. Move it over. Hopefully. Okay. Sorry, I'm moving it over so we can actually see it. So 3/4 plus 3/8. Who remembers how to do this? Should I just pull a stick?
Yeah.
Okay, so these right here are going to be rewritten as the same, and we have to pick a common denominator for 4 and 8. We could do 32, but we'd have to simplify. Emily, what do you think we should pick? You're right. She just did LCM on her paper. I watched her do it. You remember what LCM is?
Yeah. Then like you put 4 and 8.
She did this. Okay, so she says it's 8. Good thinking, Emily. And we just have to figure out what the numerators are. I'm going to pull a stick. Miguel, help me out. 4 times something equals 8.
2.
Okay. So the first numerator is a good. What do I do in the next one, Miguel? Take it times 1. Okay, so now I've got Eurydia. What's my answer?
9/8 or 1/8.
Oh my goodness. Or 1 and 1/8. That's correct. Units squared. Kind of fun, isn't it? So that took everything we've learned with fractions and put it all together in one problem. All right, let's take a look at rectangle D. This is probably the last one we're going to have time to do today, and I'll finish it. We'll finish it tomorrow. So this is pretty small, isn't it?
Yes.
I think it's less than 1 hole, so I'm not going to mess with 1 hole. How wide do you think it is?
I think Yeah.
Okay, so 3/4 is our length, right? Get your rectangle on there. Okay, so she thinks a half sideways. All right. Think it's a half sideways?
Yeah.
Okay, so this is not going to take long to solve. Who knows what I need to write? Nope, because length times width equals area, right? So 3/4 times 1/2. Solve the problem. What'd you get? 3/8.
Wait, what?
Let's take a look at the last rectangle. Now, there's kind of a hint on here because I've never used 1/3. I'm wondering if 1/3 is on here for a reason. Yeah, so it's 1/3 by 1/3. So it's a square, isn't it? So as I make my area model now, make yourself a square. It's going to be 1/3 by 1/3. I'm going to pull a stick for the answer. Abdiel, what's 1/3 times 1/3? 1/9. So my area is 1/9 unit squared